When you're ready.
Okay. Should we experiment on the human genome is a commonly asked question by many scientists today. We're going to be exploring this through 3 different lenses. First of all, Brooklyn will be showing us the economic lens. I'll be talking about part of the ethical lens. Alex will be talking about the ethical and social lens. And Kate will be looking through the futuristic lens. First, what is genome editing? The process of cutting, repairing, modifying, and developing genes is evolutionary to the globe today. This idea of genetic modification, better known as human genome editing. Since the 1900s, human genome editing has developed into one of the most influential and futuristic projects of genetic history, stated by the National Human Genome Research Institute in 2019. In 2012, the commercialization of CRISPR-Cas9 technology allowed scientists to edit on the human genome, stated by What is Biotechnology in 2012. CRISPR is a technology that scientists use to selectively modify the DNA of living organisms, stated by the National Human Genome Research Institute in 2023. This has several effects on our society. Our claim and argument is that no, there should not be experimentation on the human genome because of expenses, unequal access, societal debate, off-target effects, and designer babies. However, there are some positive effects, such as an influx in job opportunities, therapeutic methods, and increased human development research. We're basically saying that although there are some positive effects, the negative effects outweigh the positive.
The first reason we should not experiment on the human genome is how expensive it is. There are products on the market for over $1 million. For example, Zolgensma, a treatment for spinal cord atrophy, was placed on the market for $2.125 million, which is often a price tag that is unimaginable for most people. Because of these expensive price tags, it limits the access to these treatments. Low-income countries are unable to afford these treatments. Because of this, people are unable to access a treatment that could cure a life-threatening condition that they have. Because low-income countries are unable to support and pay for these treatments, but high-income countries have an easier time of supporting it, it increases our inequalities within our current health system. When looking at the price, you have to ask yourself, who's going to pay these high prices? Is it going to be left to the individuals, or is it going to be left on companies to pay for it? Insurance companies are struggling to find a way to offer a full coverage plan without bankrupting themselves. According to an article by CBS Health, if insurance companies were to completely cover these treatments, it would add $10 billion to the US healthcare bill per year. With such price tags, it will cause financial burdens on both insurance companies and individuals. Why should we experiment on the human genome if we know that it's going to cause financial and economic despair between countries and individuals? Next up is Alex talking about social.
Ultimately, this is a wealthy versus poor issue. Human genome editing is super expensive, like Brooklyn mentioned before, causing only the wealthy to be able to afford this. And with the wealthy being able to afford this technology with ease, there was concern over them using it as a service to create the perfect baby, rather than using it as a necessary medical treatment for a patient who is suffering from a genetic disease or disorder. If the wealthy use it frequently, they will take up supplies from healthcare providers, causing the poor to have an even harder time accessing this technology. Research do acknowledge and are fully aware of this unfair distribution, but are shrugging it off as somebody else's business. Urgent needs of the poor and public will become sidelined due to the wealthy taking over this technology, creating an even bigger social issue and widening our wealth gap. The solution to this issue seems simple. Put strict guidelines and rules on the human genome editing, but concerns are over if these rules will be upheld and followed as strictly as they should be. Ultimately, not everyone can be trusted to follow these rules as strictly as they should be, so we should not incorporate human genome editing into society. This decision impacts everyone, not just those who decide to use this. Possible societal effects include new defects, new prejudice, and negative genetic factors. This is a very heated argument amongst all fields and not just the medical society. At the 2015 International Summit on Human Genome Editing, the committee decided that 2 things need to happen before a decision is made. Every pro and con is weighed out and examined with detail, and clinical trials have to be run to understand every single risk, outcome, and detail that come with human genome editing. And ultimately, we need to decide if this technology is efficient enough to bring to society today. And the other question is, how will this decision be made, and how will society come to a conclusion on the answer of yes or no? This decision is still up in the air on who makes it, so making this decision even harder than it already is. And next we have Paige talking about pollution.
Future descendants could be harmed by the off-target edits of CRISPR-Cas9. According to Cripps and Pereira, CRISPR-Cas9, which is the most promising form of genome editing, has the potential for off-target effects, and these authors are with the Yale Journal of Biology and Medicine. What can happen is the Cas9 protein accidentally grasps onto the wrong region, and the CRISPR comes in and edits out the wrong gene. Even one little change in an individual's DNA could cause a change in phenotype, which would mean that one little change or mutation could cause detrimental alters or disabilities. And if these off-target effects are handed down through generations, these traits would be inserted into the human gene pool and would hurt future generations. Although human genome editing would start out only being used for medical and very severe cases, it's a very slippery slope that can easily lead to cosmetic or ability changes. With the new technology available, it's no doubt that parents want the finest edit for their kids, even if that means altering genes that aren't necessarily bad. Genetically edited kids, who Alex mentioned would mostly be from wealthier families, could have it up in society because they'd be better looking, more athletic, and more intelligent. Think about the Olympics, for example. This image shows that the games would no longer be a test of natural ability, but rather of whose genes are edited the best. These edited individuals would get better jobs and make more money. And the kids who aren't designer babies, maybe because their parents can't afford it, will be at a disadvantage in society because they can't compete with something they have no control over, their genetic makeup. Therefore, genome editing would cause future generations to live in this inequitable society. And next up is the counterargument.
The first slide of the counterargument is about therapeutic methods. Some therapeutic methods could heighten certain individuals' abilities, such as cognitive or physical effects of the mutated. They could also eliminate mutations in society due to DNA change because of CRISPR. In addition to this, they could provide possible cures for cancer, genetic disorders, or diseases. This would give people solace if they are terminally ill, give parents hope for their child's future, and make it good for future generations because of eliminating mutation. An indirect side effect of this is that it would eliminate systematic rejection and discrimination in society due to new social norms. Next is Brookly.
Another reason why editing the human genome is possibly a positive is because of the job opportunities that it has created. According to a study done by the National Human Genome Research Institute, the Human Genome Project has created many job opportunities. It has directly created over 51,000 jobs and indirectly has created over 310,000 jobs. It has also increased the income in the U.S. economy. It has created about $20 billion in personal income and $67 billion into the U.S. economy.
Along with providing therapeutic methods for genetic diseases and increasing job opportunities, genome technology would also increase research about early human development. According to Christopher Gingell at the Journal of the Royal Society of Medicine, less than 1/3 of fertilized embryos survive pregnancy. And scientists don't really understand why this is because there's not a lot of information about the development of a fetus in the womb. But with genetic technology, scientists would be able to edit genes in a petri dish, which would help scientists understand the development of cells into a fetus in the womb. This would help subsequent generations have more births and more infertility treatments.
Our conclusion is that although there are some positive effects of human genome editing, ultimately humans should not edit on the human genome because of negative effects outweighing the positive.
Thank you. Thank you.
Okay.
Kate,
Yeah.
give one specific way your thinking changed as a result of learning about Brooklyn's findings.
Yeah, one thing that specifically changed in my thinking was Brooklyn's mention of who's going to pay for all of it because I never really thought about it. And she also mentioned how expensive it would be. And it got me thinking about the divisions that would cause over the controversy of who's going to pay for it and whether it'll be with individuals or whether insurance is going to pay for it and the bankruptcy that would put them in.
Okay, thank you. Alex, if you had another team member, what other perspective could they have researched that would have made a useful contribution to your project?
They would have researched scientific. I think we focused on a lot of like humanitarian issues and like societal issues. So getting like the straight like scientific fact would add a lot and it would give us a better understanding of CRISPR like in a scientific lens.
Okay, thank you. Marina, reflecting on your colleagues' work, which one had the greatest impact on your overall understanding of the problem that was identified?
Yeah, I thought Kate and her futuristic lens had the greatest impact on my over-understanding. She showed unknown consequences that were in the future, and she argued more of our counter-argument towards like, yes, we should edit. She also showed us the uncertainty of editing and more of the negative long-term effects of those who were edited. And she showed that it could increase human development research, which is like highly unknown today.
Okay, thank you. And Brooklyn, finally. What is a way in which your team's conclusion makes you think differently about your own individual research?
Our team's resolution made me think more in depth about my current personal research. We had many different examples of different ways reasons why we should not experiment on the human genome. And my personal research focused more on like the expensive side of it and how people aren't going to be able to afford. And I think with our total research, when we came together as a team, it showed more of like how it'll affect our society, how it'll affect like the people in our society and like the different social classes.
Okay, thank you. Another round of applause.